So, good morning, students. We'll start with our lecture. Because of electricity, there was no connection available. Now it is resolved. So, we'll start with. Good morning, students. Am I audible? Is this screen visible to you?
Yes, ma'am.
Yes, ma'am.
Okay, Vita. Thank you. So, students are joining. Still, we will revise what you have studied in last lecture. Recap of last lecture. So, students, in last lecture you have studied block diagram reduction rules. Okay. So 8 rules I have explained to you. When you are supposed to remember that, you are going to solve numerical based on this rules and regulation. Okay, that is nothing but block diagram reduction techniques or rules. So first rule you have studied, just revising first. This is first rule. When blocks in series, you can replace your block like this. One block with G1 and into G2. Second rules, blocks in parallel. So if this is the situation in complicated diagram, you can replace that using one block with equation G1 plus or minus G2. Then third rule is moving summing point after a block. So this is the diagram for moving summing point after a block. Fourth rule is moving summing point before a block. So this is the block diagram I have explained to you how to reduce. Then next fifth rule you have studied, that is moving takeoff point after a block. So this is the situation and we are moving takeoff point after a block. With such a block diagram you can replace this. Rule number 6, moving takeoff point before a block. So takeoff point is moving before a block. So this is the diagram with equation I have explained in last lecture. Rule number 7, any two summing points you can interchange. So this is the diagram. Then rule number 8, any summing points having more than 2 inputs may be bifurcated, okay, by using 2 summing points. So like this you can represent, or in the reverse way. So similarly, any two summing points can be combined like this. So these are 8 rules of block diagram reduction you have studied in last lecture. Now, small part is remaining from block diagram reduction rule that I am going to explain now, and that is very important. Okay, so students, you are supposed to write the last rule, that is rule number 9, elimination of feedback loop. So draw the diagram. Meanwhile, I am admitting students. Just wait. 35 and 72. So this is the rule number 9. Rule number 9, elimination of feedback loop. Now, in your complicated control system, if this is the situation, this is closed loop control system. So how you can replace this closed loop control system by using one block only? That derivation is given over here. So students, are you with me?
Yes, ma'am.
Yes,
Okay.
Yes, ma'am.
So write rule number 9, elimination of feedback loop. Now this is nothing but your closed loop control system, block diagram of closed loop control system. Now if this is the situation in complicated control system, so you can replace this block by using only single block with transfer function G1 divided by 1 minus and plus in G1 into H1. RS is input, CS is output. That remains as it is. But you can replace these 3 blocks by using one block, and this is the transfer function for this closed loop control system or feedback loop. And this is how you can eliminate this feedback loop by using one block only. So have you drawn the block diagram?
ड्रॉइंग मॅम.
ओके, करा करा, ड्रॉ करा. सिंपल आहे, सोपी आहे. नाउ आय एम गोइंग टू एक्सप्लेन हाऊ दिस ट्रान्सफर फंक्शन इज कमिंग. ठीक आहे, झालं की सांगा मला, पुढे जाऊया आपण.
झालं मॅम.
ओके बेटा. हा, नाउ आय एम गोइंग टू एक्सप्लेन अबाउट द डेरिवेशन. हे जे ट्रान्सफर फंक्शन आहे, हे आहे फीडबॅक लूपचं ट्रान्सफर फंक्शन आहे, जे की आपण हा जो मोठा ब्लॉक डायग्राम आहे फीडबॅक लूपचा, तो आपण रिप्लेस करणार आहोत या ब्लॉकनी, एका ब्लॉकनी, and with this transfer function. So how you will get this transfer function, that I am going to explain now. Now listen to me carefully. Here is the derivation. Is it visible, students?
येस मॅम.
लार्ज केलं की ते इरेज होतंय, ब्लॉक डायग्राम मध्ये जातंय. ओके, इथेच एनलार्ज करते मी थोडंसं फक्त. Only transfer function. Is it visible clearly?
येस मॅम.
आता बघा मुलांना इथे, now this ES is nothing but error signal, okay, in Laplace transform. RS is input, BS is feedback signal. Okay, so diagram मध्ये बघा, now coming to diagram again. So this is nothing but RS is input to the process, to the summing point. Okay, another input to summing point is BS. BS is nothing but feedback signal. This ES is nothing but error signal, and CS is nothing but output. Okay, output is taken, sample of output is taken from takeoff point, that is given to feedback element, which is having gain H1. H1 is the gain of feedback element, or you can say transfer function of feedback element, and output of this feedback element is nothing but BS. So what is the equation for ES? If the sign for BS is plus minus, the equation error signal, this is nothing but error signal. Error signal is nothing but difference between this input and feedback signal, right? This G1 is nothing but transfer function of your process. So या ब्लॉक मध्ये काय आहे, तुमची प्रोसेस आहे. या ब्लॉक मध्ये काय आहे, फीडबॅक एलिमेंट आहे. So transfer function of process is G1. Transfer function of feedback element is H1. Okay, now for error signal we are writing equation from this block diagram. So ES is equal to RS minus, घेऊया आपण, minus BS. RS is input, BS is feedback signal. Okay, आता BS म्हणजे काय आहे बघा, हे काय आपण सॅम्पल घेतले. So you can write BS in terms of CS. So CS into H1 or H of S is nothing but BS. So you can write equation for feedback signal, that is BS is equal to CS into transfer function of feedback element HS. So this is the equation for BS. Now we are going to put this equation over here. So your equation for error signal ES, you can write like this: ES is equal to RS as it is minus CS into HS. आपण काय केलंय, BS रिप्लेस केलाय कुठल्या इक्वेशननी, या इक्वेशननी, CS into HS. का बरं CS into HS? कारण we have taken sample of output from this takeoff point, hence CS into transfer function of this, that is HS, you can say, is equal to BS. So BS is equal to CS into HS आपण put केलाय, बरोबर. So your error signal equation becomes like this: ES is equal to RS minus CS into HS. आता बघा काय करायचं आपल्याला. We are going to talk about CS and RS, बरोबर. आपल्याला ट्रान्सफर फंक्शन पाहिजे. So what is CS? हे CS म्हणजेच काय, ES into transfer function of this process. So this is GS, okay. G1 घेतलंय मी इथे कारण प्रोसेस एकच आहे म्हणून G1 लिहिलंय. इन जनरल आपण काय लिहितोय GS, इथे काय लिहितोय HS. So what is output? CS is equal to transfer function of this process GS into input ES. So transfer function CS, output CS is equal to transfer function GS into input ES. बरोबर. आता आपल्याला माहितीये ES चे इक्वेशन हे आहे, right? So you can write equation of ES over here. So the equation for output, that is CS, is equal to, now ES चे इक्वेशन आहे RS minus CS into HS. तेच इक्वेशन आपण इथे पुट केलंय, RS minus CS into HS, bracket complete, into this transfer function as it is, GS. So your equation for output CS is equal to RS minus CS into HS into bracket complete into G of S. So this is the equation for output, right? Now what is generalized equation for output? Or you can multiply this GS into RS, then GS into CS into HS, then take GS common. Let us see what happened. Just to simplify this equation. So your output equation CS is equal to multiplying this GS by RS, GS into RS, minus sign as it is, this GS into this term, so GS into CS into HS. H of S, C of S and G of S. You can read like this. So equation for output is equal to C of S is output is equal to G of S into R of S minus G of S, C of S, H of S. Okay. Now you can simplify further. करता येते का simplify बघा. You can simplify further this equation. Now this is CS. This is also CS. Now take this two term on one side. So this CS हे मायनस आहे, इकडे गेल्यावर काय होणार, हे प्लस होणार, प्लस GS CS into HS. Now I'm going to take CS common. आता मी CS कॉमन घेतलाय बघा, इथे CS कॉमन घेतलाय. So what is my equation? By taking CS common into bracket 1 plus this term GS into HS. इकडे गेल्यावर प्लस झाली ना, लेफ्ट साइडला गेल्यावर. So plus GS into HS, bracket complete. Now this term as it is on the right hand side, so is equal to G of S into R of S as it is. Are you with me, students? Writing the equations?
Yes, ma'am.
Yes, ma'am.
Okay, beta. Okay, beta. Okay. आता बघा, I'm taking ratio of output to the input because transfer function is the ratio of controlled output to the applied input. Here controlled output you can write as CS. C of S divided by R of S is nothing but transfer function, right? Now I am taking this C of S divided by R of S on this side and this term on this side. So G of S divided by this term is nothing but transfer function. So transfer function is equal to C of S divided by R of S is equal to G of S divided by 1 plus G of S into H of S. Now this is the equation for transfer function. I got, when I have taken input error is equal to RS minus BS. So when I have taken minus sign, I got equation for transfer function is equal to G of S divided by 1 plus G of S into H of S. Now this is nothing but transfer function of this feedback loop. Transfer function of feedback loop. So I have written over here in terms of G1 and H1. G1 divided by 1 minus plus G1 into H1. When your feedback signal BS is having this polarity plus minus. जर BS signal plus असेल तर इथे काय येणार, मायनस साइन येणार, बरोबर. जर BS signal आपण मायनस कन्सिडर केला, इथे मायनस कन्सिडर केला आपण, राइट. So you will get plus sign over here. Are you getting this?
Yes, ma'am.
Okay. Got the rule number 9?
Yes.
Okay.
Yes,
So,
ma'am.
okay, thank you, Vita. Okay. So you can write two equations, huh? Two equations. First one is CS divided by RS is equal to GS divided by 1 plus GSHS for BS is equal to minus BS. And you can write one more equation, GS divided by 1 minus GS into HS for BS is equal to minus BS. Okay. And you can replace now by using this block diagram reduction rule number 9. You can replace this feedback loop by using one block only with this transfer function. So remember this. बघा इथे 3 block reduce झाले आपले. So this is how you can eliminate feedback loop. This is feedback loop by using one block only with input RS with output CS as it is and with this transfer function in this block. Got it? Rule number 9. So
Yes, ma'am.
thank you, Vita.
Yes, ma'am.
Thank you. Thank you, students, for your feedback. The meaning is that you are in phase with the control system. Okay. Thank you for your attention. So this is how you have studied all 9 rules for block diagram reduction. Okay. So now by using these 9 rules, you can reduce any block diagram to simpler one. Any complicated block diagram you can convert into simple one. लगेच काही एक्झाम्पल घेत नाहीये मी अजून थोडस शिकवून मग आपण एक्झाम्पल घेऊया सो थँक्यू स्टुडंट्स फॉर पेशंट लिसनिंग नाउ this is what about block diagram reduction rules I have explained. Now one more thing you have to study, that is nothing but signal flow graphs. Okay, so we'll start with that. Any doubt up to this?
No, ma'am.
No doubt. Okay,
No,
so
ma'am.
we'll start with the next, that is signal flow graph. Students, is the screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, okay. वेटिंग रूम मध्ये कोण आहे? महेश. चलो. Now next point you are going to study, that is signal flow graph. Now we are in the last part of unit 1. Okay, small part is remaining, but that is very important. Signal flow graph. Okay, now before starting you should know objective and outcomes. So objective of this session is to represent a control system using signal flow graph. To represent a control system using signal flow graph. आता हे काय आहे signal flow graph? हे तुम्ही शिकणार आहात. Okay, that is similar to your block diagram. How you are going to represent your control system by using block diagram. But this signal flow graph is again one more method to represent your control system in terms of simultaneous equation. Okay. And what is learning outcome? That is course outcome that you have to remember, and accordingly you are going to learn this. So learning outcome is to calculate transfer function of control system using signal flow graph. आपण ट्रान्सफर फंक्शन कॅल्क्युलेट करणार आहोत, ठीक आहे, फॉर गिवन कंट्रोल सिस्टीम. ओके, बाय युझिंग सिग्नल फ्लो ग्राफ. ते कसं करणार आहोत आपण? सो दॅट यू आर गोइंग टू स्टडी. चला, आता व्हॉट इज दिस सिग्नल फ्लो ग्राफ? जसं ब्लॉक डायग्राम मध्ये ब्लॉक्स असतात, त्याच्यामध्ये ट्रान्सफर फंक्शन लिहिलेलं असतं. सो इन सिमिलर वे हिअर इन सिग्नल फ्लो ग्राफ देर आर व्हेरिएबल्स, देर आर सम नोड्स, there are some branches, there is a forward flow, there is a reverse flow or feedback flow. So how to represent all these things? That is nothing but all together is nothing but signal flow graph. In terms of graph, आपण flow of signal indicate करणार आहोत, represent करणार आहोत. Hence it is called signal flow graph. Okay, so let us start with. Now you have studied up to this block diagram representation of a system. हे आपण बघितलंय, transfer function of a system हे पण बघितलंय आपण. Now we are here in the third part of unit 1. So you are going to study signal flow graph and Mason's gain formula. So by using this Mason's gain formula, you are going to calculate, you are going to find transfer function. Okay. So are you with me, students? एक नवीन टॉपिक आपण सुरू
Yes, ma'am.
करतोय. All should be here. Now what is SF? SFG काय आहे? What is signal flow graph? Please try to understand. थोडी एक इंट्रोडक्शन मी तर दिलेच आहे तुम्हाला, पण still I am going to give you detailed information related to signal flow graph. Question may ask based on this, what is signal flow graph? Answer is here in front of you for your ready reference. So just go through this. Signal flow graph is a diagram which represents a set of simultaneous equation. Simultaneous equation आपण represent करणार आहोत by using SFG. So it is a diagram which represent a set of simultaneous equations. Block diagram मध्ये फक्त blocks होते. इथे काय असणार आहे? Simultaneous equations असणार आहे. So this method was developed by S.J. Mason. This method does not require any reduction technique like your block diagram reduction. इथे जसे reduction techniques आहेत, इथे काहीही reduction techniques आपण use करणार नाहीये. That is not required. Okay. It consists of a network graph in which nodes represent variables. Just मी तुम्हाला सांगितले की there are variables. So that variables can be represented by nodes. And connection between two nodes are nothing but branches. Okay. So again remember, it consists of a network graph in which nodes represent variables. Okay. आता these nodes are connected by a directed line. दोन nodes एका line ने आपण connect करणार आहेत with direction. That means with arrow. And we are calling this as branches which represent blocks of the system. The branches काय represent करणार आहे? Block of the system. Block म्हणजे कुठला block? Process block. Block diagram मध्ये आपण काय करायचो? एक block त्याच्यामध्ये process असते and we can represent that process block with transfer function g of s किंवा g1, g2, g3 so on, right? So आता इथे काय करणार आहे आपण? These nodes are connected by a directed line called branches and that branches are representing blocks of the system. The branch G असणार आहे with two nodes connecting two nodes by lines, okay, and arrow showing the direction of flow of your signal. We are calling this as or which represent blocks of the system. आता ते कसं represent करायचं हे पण मी तुम्हाला सांगणार आहे. Okay, so every branch has an arrow. प्रत्येक लाईन वर arrow असणार आहे, फॉरवर्ड असेल किंवा बॅकवर्ड असेल. That will represent the flow of signal. पण तुमचा सिग्नल कसा फ्लो होतो? लेफ्ट टू राईट होतोय की राईट टू लेफ्ट होतोय? दॅट इज नथिंग बट इनपुट टू आउटपुट फ्लो होतोय की आउटपुट टू इनपुट फ्लो होतोय? So that will be represented the flow of signal. So every branch has an arrow. That arrow represents the flow of signal from input to output or output to input. For complicated systems, when block diagram reduction methods become tedious or time consuming, then signal flow graph is a good solution, good choice. Okay, so where it is used? For complicated system, when block diagram reduction techniques becomes tedious and becomes time consuming, then signal flow graph is used. Okay. Now how to represent? Just take one example. So this is one of the example for signal flow graph. I am going to take this example later on also, but just to explain what is signal flow graph? So this is one of the example of signal flow graph. Now here, see, these are the variables denoted by nodes. Okay, this is second variable denoted by nodes. Now this is the branch with arrow connecting two variables, two nodes with this transfer function G1. So in block diagram आपण काय करणार आहे? हा आपला इनपुट झाला RS. This is output. Okay, output of first process which is having transfer function G1 and signal is flowing from input to output. So this is one what you call control block you can represent. Then this is one node, this is another node. The line is connecting this node to this node. Arrow is in this direction. That means your input is flowing from input. Now this is input to output, and transfer function of this branch is nothing but G2. Okay. Similarly here, transfer function of this branch is G3. These are two nodes. Okay, and this is closed loop. This is closed loop. This is also closed loop, or you can say feedback loop. Okay, hence the direction of arrow is here. So this is H2 is the transfer function of feedback element. Here H3 is the transfer function of feedback element. Again, signal is moving from this node to this node, connecting branches. This is nothing but your branch, and this arrow is indicating signal flow. So this is nothing but your transfer function for this process G4. हा एक पाथ झाला बघा मुलांनो. For SFG, this is one path. इथून स्टार्ट होत आहे from RS to CS. This is one path. Okay, just I am tracing the path. This is one path starting from RS. Okay, then this is second in the same direction, third in the same direction, reaching to output. This CS is nothing but your output. Okay, so this is one path of signal flow. Now trace out the another path. Starting from this input RS, you have to reach up to output with nodes and branches. Okay, so this is again node, one node, second node. So two nodes are connected by line indicating arrow, that is nothing but signal flow, and this is having transfer function G5. Similarly for this is closed loop again. This one is closed loop, but in this direction. Okay, which is having transfer function closed loop, that is feedback element transfer function is H6, whereas transfer function of this branch is G6. Similarly over here, from this point to this point, this node to this node, your signal is moving, okay, through this branch in this direction with transfer function G7, and transfer function of feedback element is H7. Feedback आहे म्हणून arrow is in reverse direction. So this is one path. Then again your signal is moving from this point to this point, or this node to this node, or this variable to this variable through this branch with this arrow indicating signal flow with this transfer function G8, okay, and reaching to output CS. Now second path for this example is like this. This is second path. Your signal is moving. Again, in the same line your signal is moving. In the same line your signal is moving, coming out of output, that is output is equal to CS. So there are two paths you can say. Path 1 is like this, and path 2 is this one. Okay, so this is the example of signal flow graph. Got the concept, students?
Yes, ma'am.
Okay. आता काही रूल्स बघूया ह्याचे पण. हा, आपण कसं लिहायचंय त्याचं So there are some variables, there are some admittance, there are source node आहे त्याला, sync node आहे. Source node म्हणजेच काय, input node. So if your, एकच minute. If your input is moving from this point to this point, so we are calling this point as source node and this point as what you are calling output node म्हणूया आपण याला, किंवा याला सिंक नोड म्हणतात आणि याला इनपुट नोड, याला आउटपुट नोड म्हणतात. दुसरं नाव काय आहे, काही पुस्तकांमध्ये असं दिलेलं आहे, इनपुट नोडला सोर्स नोड म्हणतात आणि आउटपुट नोड जे असेल त्याला काय म्हणतात, सिंक नोड म्हणतात. आणि मग त्याच्यामध्ये अजून ट्रान्समिटन्स पण असतो. सो हाऊ टू राईट इक्वेशन फॉर दॅट ट्रान्समिटन्स, ओके, दॅट आय एम गोइंग टू एक्सप्लेन यू अँड हाऊ टू ड्रॉ दी सिग्नल फ्लो डायग्राम. तर बघूया आपण पुढे जाऊ. Is the screen visible, students?
Yes, ma'am.
Yes, ma'am.
Okay, beta. So comparison of block diagram and signal flow graph. बघा, block diagram मध्ये you are going to represent your control system like this. Okay, so this is the process. In this block, process is there with transfer function g of s. What is input? This input to this process. Input to this process is r of s. Output of this process is c of s. Controlled output and manipulating input. Okay, you can represent block diagram like this in block diagram technique. Now in signal flow graph, you can represent your system like this. So this is input node, this is output node. Okay, line is connected between input and output with arrow indicating in this direction. That means signal flow is from input to output. So this is nothing but your branch with arrow, that is signal flow, which is having transfer function g of s. So ही block diagram आपण कशाने represent करणार आहोत, SFG मध्ये, like this only. Simple झालं आणखी. So only one time SFG is to be drawn and the Mason's gain formula is to be evaluated. बघा इथे, in this case, at each step, block diagram is to be drawn or redrawn. That's why it is tedious method and so wastage of time and space. Now, what is use of this SF? Only one time SFG is to be drawn and then Mason's gain formula is to be evaluated. That I am going to explain to you how to evaluate gain by using Mason's rule. So there is a standard equation. So we'll see that. So time and space is saved. So this is the advantage of signal flow graph. हे लक्षात आलं मुलांनो, सिग्नल फ्लो ग्राफ आपण कसा इंडिकेट करणार आहे. इनपुट नोड RS, output node CS. Okay, and line connected between input and output is nothing but a branch with this arrow which is having transfer function g of s. This line with arrow is nothing but your transfer function. This is process. You can represent your process by using this line along with arrow. Okay, signal is moving from input to output. So got it?
Yes, ma'am.
Okay, Bharat. Thank you, beta. Now, alternative to block diagram. Alternative to block diagram. So in block diagram, consist only branches in signal flow. Branches means system, and nodes are nothing but your signals in SFG. So these are branches and this is nothing but node. V of S you can represent by one node. V of S means input. And branches is nothing but your system or process, you can say. You can represent by G of S. आता बघूया आपण. Some standard definitions of standard terms. Nodes म्हणजे काय, branch म्हणजे काय, input म्हणजे काय, source node म्हणजे काय, sync node म्हणजे काय. ठीक आहे? So you have to write these important points. Please note it. Student, you are supposed to write. Okay. So some standard definitions or terms required in signal flow graph. So definitions of terms required in SFG, signal flow graph. Very first is node. आता मी बऱ्याच वेळेस तुम्हाला node, branches, input, output, source node, sync node हे म्हणते. But what is exact meaning of this 2, 3, 4 terms that you have to remember, okay, in proper word. आता बघा. Node, first term is node. So what is this node? It is a point representing a variable. It is a point representing a variable. Simple. Node म्हणजे काय? एक पॉइंट आहे की जो तुमचा व्हेरिएबल डिनोट करतो किंवा रिप्रेझेंट करतो. दॅट्स इट. फॉर एक्झाम्पल x2 हा x2 आहे माझा, हा एक पॉइंट आहे माझा, हा नोड आहे x2. सो हा माझा व्हेरिएबल डिनोट करतोय. सो आय एम गोइंग टू राईट दिस x2. बघा x2 ला एक एरो येतोय फ्रॉम x1 इन दिस डायरेक्शन. ओके, x2 ला दुसरा एरो, दुसरे सिग्नल येतोय फ्रॉम दिस पॉइंट in this direction. Okay, so I can write equation for x2 in terms of x1 and x3. इथे x3 आहे हा मुलांना, हा x3 इथे गेला. सो इथे जे आहेत हा आहे x3. हा x3 इथे आहे, x2 इथे आहे, x1 इथे आहे. So how to write equation for x2? x2 is nothing but my variable or node. You can say I am going to write equation for this x2. How to write? In terms of transmittance. So this is nothing but transmittance. हे लाईनला या एरोला जे इंडिकेट करतं, that is T12 is nothing but transmittance. So my signal is moving from x1 to x2 node in this direction. So I'm going to write transmittance T. Signal is moving from 1 to 2. So I have written T12 into x1 is nothing but my x2. Got the point? So I have written x2 is equal to T12 into x1. Okay. आता दुसरा सिग्नल बघा, प्लस दुसरा सिग्नल येतोय माझा फ्रॉम x3 to x2. बरोबर. So what is transmittance? Transmittance I am going to write in terms of T. T is not time, huh? Transmittance. My signal is moving from node 3, x3 to x2. So I have written T32 from 3 to 2. So T32. माझा सिग्नल ट्रान्समिट होतोय from node x3 to node x2. So I have written equation for transmittance. T32 is the transmittance between x3 and x2. यश समजतंय का बेटा? Are you with me? यश कुलकर्णी समजतंय का? So I have written
Yes,
plus. Okay, beta. T32 into x3. So this is the equation for x2. So x2 I have written from this diagram. I have written equation for x2. Now in this signal flow graph there are 3 nodes, x1, x2, x3. बरोबर. Branches किती आहेत? 1, 2 branches, hence 2 admittance. Okay. आता बघा, यश प्लीज तुला कॅमेरा ऑफ करशील बेटा? ते सगळ्या मुलांचं तिकडे लक्षात आहे, प्लीज. यशला मेसेज टाका कोणीतरी प्लीज. यश आणि हा कोण आहे? अभिषेक. स्विच ऑफ युअर कॅमेरा, अभिषेक. चलो. So coming to next term, that is branch. So a directed line joining two nodes, a directed line joining two nodes is nothing but branch. Just a second. Okay, coming back. Huh. सो इज दिस क्लिअर? नोड म्हणजे काय समजलं मुलांना? आर यू विथ मी?
Yes, ma'am.
ओके सुशांत, थँक्यू बेटा. आता ब्रांच, line connecting between two nodes. We are calling this as branch. A directed line joining two nodes. ही जी लाईन आहे joining two nodes. हा एक नोड आहे आपला x1. हा एक नोड आहे आपला. Suppose this is x1. x1 नोड आणि दुसरा नोड आहे आपला हा इथे x2. So line joining these two node x1 आणि x2 हे जे दोन टू नोड्स आहेत त्यांना जॉईन करते ही लाईन with this arrow shows signal flow and we are calling this line as branch. Okay, so directed line joining two nodes is nothing but branch. Okay, now coming to next term, that is input node or source node. Input node लाच काय म्हणतोय आपण? सोर्स नोड म्हणतोय. आता हे काय आहे इनपुट नोड म्हणजे? सो नोड which has only outgoing branches is input node. So this is x1 is input node, फक्त outgoing branch आहे, बरोबर? In this case x1 is input node. In this case x3 is input node. Okay, so node which has only outgoing branches. Incoming नाही म्हणत आहे मी, outgoing branches. आणि outgoing branches असतील तर आपण काय करतोय? x1 is calling as input node or source node. ठीक आहे, हे लक्षात आलं? Similarly, you should know the next term, that is output node. Output node काय आहे बघा? Output node or sync node म्हणतोय आपण त्याला. So only incoming branches. Output node means only incoming branches. Then mixed node or chain nodes म्हणतात त्याला, has both incoming and outgoing branches. तर इथे बघा या नोडला काय आहे? इनकमिंग पण आहे आणि आउटगोइंग पण आहे. For example, so chain or mixed nodes is nothing but which is having both incoming and outgoing branches. एक मिनिट हे काढून टाकते. Now transmittance, coming to this next term, transmittance. So what is transmittance? हे मी explain केलं already. Again for your reference, what is transmittance? It is the gain between two nodes. It is generally written on the branch near the arrow. या arrowच्या जवळ लिहिलं जात आहे on the branch. So this is nothing but gain, similar to your block diagram. Block diagram मध्ये आपण gain जसं लिहितोय प्रोसेसची, G of S आपण लिहितो की नाही, G1 किंवा G2, G3, G4 and so on like this. So it is the gain. Transmittance is nothing but gain between two nodes. Okay, and generally written on the branches. म्हणजे ही जी ब्रांच आहे याच्यावरच तो लिहिला जातो. And that is represented by using branch and arrow. Signal flow. So is this clear? What is node? What is branch? What is output node? Source node. What is input node? Input node is source node. What is output? Output we are calling as sync node. What is mixed node or chain node? Which is having both incoming and outgoing branches. And transmittance is nothing but gain of two nodes. Okay. आता हे एकदा ह्या टर्म्स तुमच्या लक्षात राहिल्या, बरोबर डोक्यात फिट करून घ्यायच्यात या टर्म्स. ओके, फर्स्ट वन इज व्हेरिएबल, सेकंड वन इज ब्रांच. व्हेरिएबल कुठे असतो? दिस x1 इज व्हेरिएबल, दिस x2 इज व्हेरिएबल, this line is nothing but branch. Okay, this x1 is input node, this x2 is output node. Okay, this one is mixed node which is having incoming branches and outgoing branches also. Okay, transmittance म्हणजे काय? Transmittance is nothing but gain between two nodes. ह्या दोन nodes मधली gain म्हणजे transmittance आहे. So how to write this T12? Signal is moving from x1 to x2. So T12 you can write on that particular branch or nearer to that branch, nearer to arrow, you are going to write transmittance. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, चला पुढे जाऊया आपण.
Yes, ma'am.
आता बघा 2-3 more terms you have to remember. What is path, what is forward path, and forward path gain. So how to write that? Okay, so path. आपण ह्याच एक्झाम्पल मध्ये मी तुम्हाला दोन पाथ दाखवले होते, राईट? P1, P2. Same thing is again I have taken same example again. So path, next term is path related to signal flow graph. So it is the traversal of connected branches in the direction of branch arrow, such that no node is traversed more than once, is nothing but path. Now what is forward path, backward path, and forward path gain? So forward path is nothing but a path which originates from the input node and terminates at the output node, and along which no node is traversed more than once. That is nothing but forward path. So this is forward path. This is forward path. This is forward path. Okay. Now this G2, G3 are nothing but forward path gain. आता बघा forward path gain म्हणजे काय? It is the product of branch transmittances of a forward path. Is nothing but forward path gain. So you have to remember all these terms related to signal flow graph. Now this is the example. Now I'm going to write equation for path 1. I have shown already an equation for path 2. So this is one path. Okay. In previous example, the same example I have taken again. थोड़ा सा enlarge करते हैं. So this is one path, P1. This is second path. Okay. Now I'm going to write equation for forward path gain, P1. So what is P1? P1 is equal to transfer function of this branch, transfer function of this branch, transfer function of this branch, transfer function of this branch. So you can write P1 is equal to, you can write P1 is equal to G1 into G2 into G3 into G4. So this is the forward path gain. Okay. Now for second path, P2. Now this is the second path. Okay. So you can write equation for forward path gain. P2 is equal to G5 into G6 into G7 into G8. G5, G6, G7 into G8. Now this is the equation for P2. So this is how you can write forward path gain. Is this clear, students? Any doubt up to this?
Yes, ma'am.
Any doubt? So students, so we'll stop here. Yes, time is over. Students, today you have studied the last rule of block diagram reduction. Now I have started new topic, that is a signal flow graph. So you have studied how to represent signal flow graph, what are the basic terms used in signal flow graph, how to write equation for transmittance, how to write equation for forward path gain. Okay, so I have taken one example. So how to denote transmittance. All these things you have studied in today's lecture. Got it? Any doubt?
No, ma'am.
Okay, thank you students for attending this lecture. So please remember all these terms. We are going to solve the equation now using SFG, signal flow graph. मी कसं ट्रान्सफर फंक्शन कॅल्क्युलेट करायचं हे आपण बघणार आहोत by taking small example in next lecture. So thank you students. Please write your roll number with understanding in chat box. Thank you all. If you are having any difficulty, any doubt, you can ask me. Students, please write with understanding. You are welcome, Vibha. Thank you for patient listening. I have taken 5-7 minutes extra. That too within lunch break. So thank you all. Please write your roll number in chat box with understanding, then you are free to move.